Okay, the edge of my eraser here is a knife edge. And imagine that you have a hardwood floor in your house. Please don't do this. Take the knife, sink it into your hardwood floor, and then keep going forward. What you'll find out is that it is very, very difficult for you to instantaneously move the knife perpendicular to its path. Okay, it's going to take some effort. So it's almost like the teeth of this blade is sunk into the wooden floor, and then you're moving along a particular predetermined angle. And if you're doing that, it is instantaneously difficult to move perpendicular to the way you're moving. Okay, so which means that the dot product of the velocity vector of the center of mass at the contact point and the normal to the path is going to be 0. That's essentially what that constraint means. Okay, so once again, take a knife, dig it into the ground, keep moving forward. At any instant in time, try to move laterally. It will be very difficult to do it. And typically, what we say is it is impossible to do it. So you are constraining the velocity to be along the tangent to the leading edge of the knife. That's what the problem is. Okay? So this is called the knife edge constraint. I'm going to stop here. We have 4 minutes. I will not be able to do justice to it in 4 minutes. So 2 problems that we are going to look at in the next class is the knife edge constraint and then a rolling coin. Just the constraints, not the equations of motion. We are not there yet. But we will look at the constraints for a rolling coin. Remember, in 2D, roll without slip for a disk was a holonomic system. You will find out that in 3D that's not the case, even if it is rolling without slip. Okay? Thank you for your patience.